Thank you. Welcome, good afternoon, ladies and gentlemen, to the presentation of Axual this afternoon. Today we're going to talk about scaling Kafka across 200 plus DevOps teams by providing self-service and data governance. To give you a little bit of an introduction, my name is Jeroen van Disseldorp. I'm CEO and founder of Axual. We started in 2015 with implementing Apache Kafka for larger organizations. And we're going to go through some of the learnings here today about what we found on how to implement that in bigger organizations. Well, because of my PowerPoint presenter mode, you're moving a little bit away to the background. So if my colleague here next to me, if there's anything that you want to ask in the meantime, please let me know and he will nudge me. A quick introduction of Axual. As I said, we were founded in 2015. We're a venture capital funded company. Currently consist of over 50 Kafka experts across the EU. And I must say, a part of some other continents in the meantime. We are a Gartner representative vendor, being mentioned in research that Gartner does in event-driven architecture. SOC 2 and ISO certified, approved cloud provider by the Dutch Central Bank. So we provide our platform both in a license form as well as SaaS offerings for larger enterprise customers. We're HQ'd in Utrecht, which is a central city in the Netherlands. As I said in the introduction, we do Kafka implementations. I'm going to tell you a lot more about that. Mostly for bigger organizations with 1,000, 2,000 plus employees, where Kafka is becoming a central hub in the organization to do event streaming with. One of the examples, which is one of our first customers, is Rabobank, which is one of the top tier, top 3 banks in the Netherlands. They set out to become a 100% digital bank in 2015, and they're well on the way on achieving that, with the goal of becoming a real-time and event-driven bank, and thereby serving their customers a lot better and improving the overall banking experience. We started out with the Kafka implementation there in 2016, 2015, but the first go live was 2016. And since we've moved to a completely self-service type of implementation, where over 200 teams are working in parallel on the same centralized Kafka. They have about 300, 350 data streams in production currently, and around 600 applications that integrate on a daily basis, communicate with Apache Kafka. So really started small, and by going through a lot of growing pains, we experienced, and also Rabobank experienced, what it takes to do implementations of Kafka in a big organization. Nowadays, it's much more common. So it's also nice to see what typical returns our customers have. So with Rabobank, they currently save around €500,000 per year on Kafka maintenance because it's a fully managed platform for them. And I will tell you how that is to be operated by so many different teams. Another customer also doing well in the energy sector. One of the earlier customers is Eneco, who has managed to save about 20 to 30% of energy in the heat grid that they operate, amongst other types of gains that they achieved. So today we're going to talk about how to mature Kafka implementation in your organization. And to do that, we're going to fall back on Gartner's maturity model for event-driven architecture, which is depicted here into 5 phases. So we're going from 0 to pervasive event streaming, basically. And 0 would mean, well, summarized, there's no Kafka. Initially, when organizations start with event streaming, what you often see is that, well, there are a few applications or maybe a few modules within an application that want to exchange events with one another, but there's no real standardization, and there are no really good formal agreements between parties. So what you then get is that if there is any Kafka at all or any event-driven architecture at all, it's really not standardized. It's completely isolated from other applications. But over the course of time, you would probably see that the amount of data sources and parties that want to do streaming, they're increasing. So volumes are increasing, the frequency is increasing, and at some point, it starts to make sense to get a group of architects together and think about how to organize this event streaming and event sharing a lot better. This is usually the place where, or the point in time where companies start to think about a brokered type of event-driven architecture. So put a broker in the middle, and that one will solve all your problems, right? Right. So then typically what the internet brings us is a lot of choice. Organizations, they start looking for what type of event engines are there out there. I can choose roughly 3 kind of categories. I can choose SaaS options, I can choose open source options, or I could go for proprietary options. Typically, what we found over the past years is that, well, in 2/3 of the cases we're involved with, Apache Kafka is the preferred engine of choice for event streaming. So the organization chooses Kafka and is going to happily implement Kafka, right? Right, but then also you run into a few challenges. Challenges are, amongst others, getting to know the technology. Kafka has quite a steep learning curve. There's a lot of terminology. There's a lot of edge cases that you have to be aware of. On maintenance day 2, a lot of errors, they arise that you never heard of, that you never thought possible. And especially as the complexity with implementations grow, more and more applications start to make use of the platform, the complexity of failure scenarios also increases. So this is still the phase in which you have maybe 4, 5, max 6 use cases on a common Kafka broker. So you can still cut corners in terms of security, in terms of governance. This is really localized project level Kafka still. But if you want to overcome these challenges, then you should have a good Kafka setup. But more and more of these projects, they may be installing their own Kafka, they may be managing their own platform, and at some point, the overhead of managing all these Kafka installations becomes so big that there's always this bright guy in the organization that says, hey, shouldn't we move to a centralized Kafka? And then easily pictures like this are drawn. So we're going to move to a centralized phase. We're going to implement a central Kafka. We're going to put all the departments of an organization around the central Kafka, and everybody will be happily sharing their events and getting the events from others through the central Kafka. Terrific, but then you run into typical personas in an organization that also bring in some requirements. Typically, you would run into a data owner saying, yeah, that's all nice. I'm going to share my data on a common platform, but I work for a bank. I'm responsible for payment information, for customer information, or I work at a grid operator, and my responsibility is to guard meter data. So how can I, as a data owner, remain in control of who gets to see my data? A crucial element in most enterprises today. Typically, an IT architect would be saying, well, what about the security of this platform? Does it have a proven track record? Is it future-proof? Developers, they remember the times of the enterprise service bus, where a central team had to onboard them and was the only team that could make changes to the enterprise service bus itself. So if you want to connect your application to the enterprise service bus, you would be the first on their backlog in 3 or 5 months. So developers are mostly looking for independence, developing quickly, and especially without any dependencies on other teams, because they should be in control of their own backlog execution. Operators, of course, are looking for stability in the platform. It has to be maintainable, predictable. And finally, procurement says, well, I want compliancy, and I also want a credible vendor that I can fall back on in case we run into any difficulties. Well, if you all explode these wishes, these needs into requirement lists, you typically get requirements like data governance. I want data lineage in my platform. It should be GDPR compliant. An architect would be saying, I'm looking for replication solutions. It should be hybrid cloud. I want end-to-end encryption, et cetera, et cetera. So this now all of a sudden becomes the backlog of the central Kafka team. Because remember, we're still implementing this as a central Kafka solution. So the central Kafka team is suddenly building their own data governance mechanism. It's setting up the foolproof security, providing self-service to DevOps teams, and it's all of a sudden supporting a whole Kafka stack. So this is not anymore just a Kafka, a schema registry, and a REST proxy. Now all of a sudden there's a complete stack that you have to maintain, and there's a lot of customers that you have to serve because every internal DevOps team all of a sudden is an internal customer. But even if you were to overcome this phase, then of course heaven looms. Because if you can overcome this phase, then you can move on to the more advanced Kafka usage and ultimately into the pervasive enterprise type of event-driven architecture. There are still challenges in these two phases. So challenges like, how should we define our organizational standards? What are the governing Kafka catalogs, the schema catalog, the topic catalog, the registered application catalog? How can I speed up the team onboarding? There's a new feature team starting. It has to implement a specific piece of the website, or it has to implement a specific business function. How can I onboard this team as quickly as I can? And of course, the scope of the entire Kafka grows, because as the teams onboard, the criticality of Kafka increases, and also the business impact of Kafka then all of a sudden increases. So this is really the Kafka everywhere phase. The nice thing is that most of the technical challenges in this phase have been solved already. So what you're looking at here is mostly the organizational challenges, how to work together, how messaging schema are defined in a standardized way, who owns what exactly. So typically, what you can take away from this path that we're walking so far is that well, the most difficult phase is to get from the brokered to the centralized phase, because then big chunks of functionality are all of a sudden needed. And those chunks are the data governance needs, self-service needs for developers, and of course, to get the security all in place. But there's actually quite a wall in between those phases. Going from brokered to centralized is not as easy as it seems, because in the brokered phase, you have a plain Kafka, which is really like a middleware messaging type oriented tool. And in the centralized phase, all of a sudden, you run into these enterprise requirements, and there's no standardized solution for that. And this is usually the phase where Axual comes in, because we aim to really allow scaling of an organization around that middleware platform, around that open source streaming engine. This is the way that we do that. So we usually divide our platform into 3 layers. We build upon generic infrastructure such as Kubernetes. We configure that layer, so that's why it's always drawn in the architecture pictures. Usually we're just users of Kubernetes. So as long as it's configured correctly and there's a bunch of needs that it fulfills, then we can work with that particular platform. The 2 layers on top is actually what makes up Axual platform. So it's divided in 2 layers, the technical layer and the more functional layer. And the technical layer, this is where you deal with Kafka. So you can have, for the Kafka knowledgeable, you can have single cluster solutions, multi-cluster solutions. There's message offset and schema synchronization that you can do between different Kafka clusters. Basically, this is the layer where you decide how your event mesh is set up. If you produce any event on any Kafka cluster, you can have it replicated and make sure that it shows up on the other end of the world where the consumers are that need to consume this event. So if that data logistics is completely designed, then you would have a technical maintainer maintaining this whole platform. So this is typically a Linux person, a Kubernetes operator, able to look at dashboards, restart pods if necessary. Typically somebody that does system maintenance. That is completely not the person that we intend to do functional maintenance with. Because functional maintenance is completely left up to individual teams that are able to log in through self-service and able to define topics, a messaging schema. They're able to grant and revoke authorizations to individual topics. That whole functional maintenance is completely left up to teams. So they can do that themselves without having to worry about performance and availability, because that is the responsibility of the technical maintainer. These teams, they still create streaming applications, of course, which do interface directly with Kafka. So they build out producers, consumers, Kafka streams, apps, you name it. Anything that has a Kafka interface is still able to communicate with the Kafka protocol to our technical layer. But besides, and this is really something that we see growing over the past 3-4 years, there's also an increasing need in enterprises to do automation, to do CI/CD, so configure our platform through the data governance layer from a CI/CD pipeline, and also to maybe have GitOps, it's like a functional configuration items defined in your own Git repository, and have those automatically deployed through a Terraform pipeline. That's all tooling that we deliver the whole platform with. So if you then look at what makes a streaming platform and what makes an enterprise streaming platform, we really say that the streaming platform is taking care of your data logistics. It takes care of data movement, getting data from A to B. But an enterprise streaming platform is really a platform where the whole data governance, including data ownership, data stewardship, is implemented centrally in a way that is compliant with most regulations, such as the banking regulations and energy sector regulations. So what this typically looks like, and this is just to give you a small impression of what you can expect in our platform. What this typically looks like is that you can visualize flows on how data moves between applications and moves to a topic, gets consumed by other application, and is then shipped off to yet other topics. So data flows, data lineage is completely visualized, and this is always up to date. There is a complete request flow for teams that want to have access to particular data items, to particular topics. You can request to, in this case, as being a consumer on a particular topic, and you request your approval. The data owner would get a notification saying that somebody wants to access your data. Do you approve? Do you deny? And as soon as you approve, then access is granted on a Kafka level as well. And from that very second onwards, your application can start to produce its information on Kafka. Of course, you also define your topics in the same environment. And these are just a few screenshots to illustrate how we help getting the users define their own piece of the pie, basically. Some features that are a little bit harder to show, but we, as I indicated, we support multi-Kafka and a multi-tenant, which means that any type of logistics that you may have, any data locality restraints that you may have, we can implement that by single or by multi-Kafka setups. Security is really battle tested. There's a lot of auditing that takes place at our company. We have external auditors coming in. We do penetration tests, both on infrastructure as well as on API level, to make sure that the platform is absolutely hardened and no strange things can happen to your data. And finally, of course, the most important one is the self-service for DevOps. In the Rabobank example that we started with, there's currently over 200 individual teams working together on a common platform, requiring less than half a FTE of maintenance in production. So that's quite the accomplishment, I think. So overall, for the positioning, I hope you can take away this mental picture. If you're doing incidental, there's probably no organization. If you start to do brokered, we see a lot of project level Kafka that arises. But as soon as you want to go centralized or once of pervasive, this is really the point where Axual comes in to as one of the solution providers to help you get that centralized Kafka in place. And to finally close off our presentation for today, one of the things that we set out to do some years ago is to really provide this self-service layer into an enterprise grade package where Kafka is already included. Most customers didn't have Kafka in the past, but nowadays we see more and more customers already having an existing Kafka. So instead of replacing that whole platform, we're also announcing that the self-service layer will be available individually as an add-on to any existing Kafka from any vendor. So that allows you to not completely reorganize your Kafka installation. If you have contracts for that, if you have a service provider for that, that's all fine. The whole data governance layer is going to be separately installable on top of your existing Kafka. And that brings me to the end of my presentation. Are there any questions? I see a question here. How vulnerable is the central Kafka as in uptime, down to data centers, etc.? Good question. There are different types of architectures that we support. We support dual data center setups. We support the 2.5, typical 2.5 data center setup that Kafka often calls the stretched cluster setup. There's many different ways in which you can increase the uptime of a central platform. We do that both in cloud as well as on data center. Sometimes there's even hybrid setups where failover from cloud to on-prem or from on-prem to cloud takes place. So there's many different ways in which you can increase the availability, the uptime of the central Kafka. In practice, this is a series of nines. I won't go into details on specific situations here, but 4 nines are definitely achievable. I hope that answers your question. I see a second question coming in. Can Kafka be implemented on Google Anthos platform? Good question. That's something that I would have to answer maybe later, because that is something that I would put on my technical engineers, if you don't mind. Don't have the answer for that. What is your key differentiator in comparison to other solutions in the market? I think what our key differentiator is that we enable large-scale collaborations on a central Kafka. So where other Kafka solutions, they still require a central Kafka team to do part of the functional maintenance, so to create your topics, to set it up, to register the permissions properly, to register the schema properly. That is completely offloaded in our platform to the individual teams that want to connect their applications to Kafka. So the technical maintenance is really technical maintenance, looking at the dashboard, doing capacity management, doing performance management, making sure the platform is always available. But as long as it runs, everybody can do their own business on the platform. We talked about the Rabo example. They have finance information, payment information, savings information, credit card information, mortgage information, lending information. All of these typical events are floating on the common platform. And we make sure that with self-service, only the applications that are eligible to access certain pieces of information, only those applications have access. So typically, I think a typical customer organization would go around 1 billion events per day. 1 billion events per day, all on a common platform, and we make sure that that is all guided in the right directions. Do you think the Kafka approach will be an industry standard for large enterprises? Good question. I think to many enterprises it already is. You saw a few of the logos of customers that we already serve. There are definitely a lot of large enterprises that use Kafka. Whether they use it as a central means, that is a good question, because that amount is still relatively low, I would say. But to a lot of departments, to a lot of projects, I think Kafka is already quite the standard. And even in, you see that in enterprise packages as well, right? SAP has a standard Kafka connection. I mean, ServiceNow, all these big tools, they all have Kafka connectors. So in that sense, all larger enterprise packages are already prepared to interface with Kafka. And that wouldn't be the case if Kafka is deemed to not be a standard in large enterprises. Okay, I hope that answers your question. I don't see any more questions coming in. So then I think we can round up. Thank you very much for your attendance. If there's any more questions, then me and my colleagues will be wandering around. And there's also a panel discussion coming up later. Hope to see you there. Cheers.